We want to take a look at the result generated now. The best way to visualize the data is using DTMaster, and in DTMaster we can load the data and check the data, edit the data, and also export results out of it in this case. So we will start DTMaster and we will go to the Applications Master and say Capture DTMaster. In DTMaster we will find the Surface Area tab on the left side, which we can select, and in the Surface Area tab all processes done in Match3dx or Match-T are listed and visible. So here are the steps from the chapter 5. We go to Applications Master, have the project loaded, go to Capture DTMaster, and when DTMaster opens, we can find here on the left side these tabs, and there's the Surface Area tab, and here we see the area ID from the process DTM that we just did in the previous video. Each area that is listed here shows its boundaries. So in our case, the DTM process has here one boundary. If the project would be very large and one boundary will be filled with more than 5 million points, then we would automatically split the result into multiple tiles, and then we would see here a tile structure over our project itself located. So this is the tpix shapefile, and we have to think in the whole way like a database. So first we need to connect to the database, and this is exactly what we do. We select the area and we load or access this database with point clouds. So now we have access to the data. We see it's visible, we can access it. The light bulb is about the boundary, so we can then switch on and off. But still the point cloud itself is not loaded. And this is exactly the reason. If we have a very large project, we can have multiple 100 millions of points, and then the interaction of the DTMaster editor would here not work nicely. So therefore we just want to load the tile data that we are interested in, and this is done with the tpix tile selection. Here we drag a box, and everything touched by this dragging box, so I keep the left mouse button pressed, this data is be loaded. In my case it's only one tile, and then the point cloud is loaded into DTMaster. When selecting the points, typically recommend to load 1 to 4 tiles as just mentioned, so to stay within a range of 2 to 10 million points, which is a good amount of data handled for DTMaster for the editing. DTMaster offers a large variety of editing tools, and we will not cover them here in this video. This is then explained in the reference manual of DTMaster. We want just here show a very short functionality where we will fill the gaps from our building exclusion areas, and then a typical possibility is then also to export the current loaded data into a raster in DTMaster itself. As we used morphological data in the DTM processing, we see that all the building shapes here don't have any points inside. So therefore these are then gaps, and when we take a look at the data, this is good because all the points on top of the buildings have not been matched and they are not inside our result. But of course we want to have these gaps now filled with points on the ground, as we want to generate a terrain model from the data. And this can be done in an easy way. We can here go to the Terrain tab and place these filled points into one of the typical last layers. We will in this case select here a layer that has no points at the moment. So when we take a look here, we see that most of our points are here in the created layer, 20,650 points. Some are in low reliable and medium reliable. We will not cover this in this video here, what the points are. And we will place the points here into ground synthetic. So I will right click here, say set as active layer, and we can see this is now our current layer. It's visible. I will just change the color so we see the filled points will now be yellow. And we will select from point, interpolate gap project, go to the tool options, and as my grid here already has a 2 meter grid spacing, I will again write a 2 meter grid into our gaps. The function automatically searches for gaps, and then when we start, then these gaps are filled automatically, which is nice. We also see that sometimes when the polygon is not rectangular, we also have these interpolations over these bridges in this case here, but for us not so important. We want to just showcase then another thing, which is then the commitment of the data into our final result. So here we see now the points are nicely interpolated on the ground, not on top of the buildings, and therefore now we can generate from this data here a final product. This can be done in DTM Toolkit, which is our preferred tool for this, but also a possibility in DTM Master is directly when you have here your data loaded to run file export raster data, and then we can generate here for this process an export, and I will call it here demo 2, and then save it. And all the data that is activated for interpolation, I will show it immediately, this will be used for generating this DTM. So interpolation flag here are these flags. I can also show them here a little bit what they mean. So I have here some points, and some of these points are here low reliability. And if I switch off the interpolation, then you see how the contour lines here are impacted. I can also show it here on the shaded relief, so with the data, without the data. And depending which data I activate, then this will have an influence on our raster export. And typically you put points into low points or into vegetation or points that are off ground, and then you would not use them for your process. So you would then say don't use the low points, don't use the medium vegetation, and then this will not be used in the raster processing here. So this is then our output, and we can output this as a SCOP DTM or as a ASCII grid, which is a very common raster format. But independent from the export of this raster, we still need now to handle our edited point cloud in our TPIC structure. And this is important, so we go back to the surface area, and in the surface area we can now say, okay, I want to commit the data back to my database of my TPIC structure. So then all these yellow interpolated points will be part of my TPIC structure again. Or I say I want to discard, then all these changes will not be written back to our database. So when we look here at our output folder, this is the last file. And when I will now say commit, then now 1643, the filled gap points will be part of this last file. And so my date will change with these changes of the point cloud. So committing, and then we take a look, and then we see 1643, and also the size of my last file has changed. And now this data is stored, and we can then continue to use this data for other processes, or we can also load it a next time again and continue our work. And that's it. So now we are finished with this tile. We can now again use the tile selection tool. If we would have multiple tiles, select the point cloud from the next tile. Or if we processed multiple areas in Match 3DX, then we could also say we want to unload this TPIC structure and this area. And then if we have a second area, we would select the second area and then load the next area and work on this dataset. Okay, let's just summarize. So in our case here, we filled the gaps with the fill gap project function. Then we were running the file export raster, and depending which layers of an active interpolation flag, this data is then used in this raster export. And then after we defined our output file name, we could also define our raster size, so you could also downsample it if you want. And independently from this output is the point cloud itself. So here, this TPIC structure point cloud, we can here commit the data, and then these changes we have done are stored in this last file and can always be accessed from our TPIC structure in the info world. So this is about the processing of the point cloud, the DTM process workflow, with the possibility to visualize the data in DT master, doing editing and also committing the changes. And then of course the next process would be orthophoto production or contour line generation, but this will not be covered here in this video. So thank you very much for watching this video and have a good day.